Okay, on the semester 2 extended response, number 1 says your friends on Facebook triple every month. You start with 100 friends. Make a table to show your friends for the first 7 months. So we need a table here. And I'm going to add on a number 7 here. And so it says that it triples every month. You start with 100. This is exponential growth. Remember that A is your initial amount, so A will equal 100. B is our common ratio. We are going to continuously triple every month. So in the beginning, we start with 100. Now, rather than entering this in one at a time, such as 100 times 3 to the first, and then we can hit times 3 times 3 times 3, I'm going to go into my y equals in the graphing calculator, and I am going to enter in my equation. Now I'm going to go into the table, and at 0 we're at 100, at 1 we're at 300, 2 we are at 900, 3 2700, 4 8100, 5 24,300, 6 72,900, and then 218,700. Okay, number 2, you are collecting pop tabs for charity. The number of tabs doubles every week. If you start with 10 pop tabs, make a table that shows the number of tabs after the first 6 weeks. So we're going to start at 10. This is another exponential growth. A times B to the power of X. A is our initial amount. We started with 10. B, we double each week. So again, I'm going to go into my y equals. I'm just going to enter this into my y equals. And then I'm going to go into the table by hitting second and graph. At 0, we start at 10. 1, we are at 20. 2, we're at 40. 3, 80. 4, 160. 5, 320. 6, 640. Okay, and numbers 3 and 4, it says to graph the following. Okay, since we could use our calculators on the final exam, I'm going to enter this function into the calculator. I'm going to type in 2 square root of x plus 1. And then I'm going to go into the graph, take a look at what it looks like. So now we know the shape. Now I'm going to go into the table and I'm going to take a look at some clear points. Okay, we're not going to drop below -1, 0. Then at 0, we're at 2. 3, we're at 4. I'm going to see if there are any other integers here. 8, we are at 6. And connect them with a smooth curve. Number 4, our graph is 3 times root x. So I'm going to go into my y equals. I'm going to type in 3 times the square root of x. I'm going to take a look at the graph first. Remember, if you don't see the graph, there are a couple of things to check. Make sure that your stat plots are turned off. The other thing to do if you don't see the graph is to hit zoom and then number 6 for standard. Okay, so it looks like we're starting right around 0, 0, but I'm going to go to the table and look for some nice points to plot. So we have 0, 0, 1 up to 3. My next two integer values are at 4, 6, and then 9, 9, which is not on the graph. Okay, and number 5, it says circle the graphs that represent functions. So remember, what we want to do is the vertical line test or the pencil test. Okay, if you were to take a pencil or a line, you want to make sure that it only touches the graph at one point. Well, we could draw a vertical line through this vertical line, so this one is not a function. Through this one, we could draw a vertical line through any point on our parabola, and it is only going to touch the parabola at one point. So this one is a function. Number 5, we have a line. This line is a function. We could take our pen or our pencil, we could go across the line. It's only going to intersect the line at exactly one point. So this graph is a function. The third one, again, we could draw a vertical line through any point, or we could take our pencil or pen and go across this wave, and it's only going to intersect the graph at only one point at a time. So this is also a function. Number 6 says circle the graphs that are not functions. So number 6, we could draw a vertical line and touch through 2 points. This is not a function. Number 6, any vertical line that we draw through our given function will only intersect at one point. So this one is a function. Number 6, again, vertical lines. Looks like each vertical line will only intersect our function at exactly one point. So this one is a function. Again, we're looking for not a function. Okay, and the fourth graph here, if I draw in this vertical line, it intersects at 2 points, which means this is not a function.